represents the fastest that the enzyme can turn over, and it's equivalent to K2 times the enzyme concentration. Why K2? Talk about that. Why is it K2? Take a minute to talk about that. Given this enzyme concentration, but we can increase the formation of the product by adding more enzyme. And that's why we take into account our enzyme concentration. Okay, right. So Vmax is our K2 times the total concentration of the enzyme, proportional to E. We've already talked about what happens if we change it. All right, let's talk about Kcat. Kcat is the rate constant of the rate limiting step, and for our purposes in this class and for the extent to which we're going to carry this topic, that is K2. K2 is our rate limiting step. All right? And Kcat is different because, well, how is it different? Somebody tell me how it's different. I bet somebody knows. Actually, check with a friend so you increase your bravery. Make sure you know why it's different than Vmax, and then somebody be prepared to tell me. Okay, 30 seconds. That's right. And so mathematically what that means is to get get KCAT, we're going to divide Vmax by our E total. Right? So this is a constant, right, where our Vmax can change. All right, good job. Okay, so at this point, I'm going to turn you loose to your peer mentors after I give you some instructions. Peer mentors, feel free to spread out. You can come up here, you can go out into the hallway, get so that you can be with your group of students and talk to them and have a good discussion about this. I'm going to give you about 20 minutes together, and I want you to consider these things. Okay? So there's this question from your case about comparing two enzymes who have different KMs. I want you to really make sure you've got that. What does that mean? I want you to make sure you know how these experiments are set up, and I want you to talk about the plots. Okay? And if you have other questions, that's fine too, but focus on these three for sure. And then when you come back, we'll see what you learned, do a little bit more with it. Okay? You may go. Wrapping up, but I want to put up some student responses to this question from the past, and I'd like us to critique these. Okay, so when I ask other students like you to respond to this question, here's what some of them said. Number one, a higher Km means that for enzyme 1, the ratio of ES complex falls apart to ES forms is higher than for enzyme 2. Number 2, if enzyme number 2 has a lower Km than enzyme 1, enzyme 2 reaches the point where all of the enzymes are bound to substrate at a lower substrate concentration than enzyme 1. This also means that enzyme 2 is more efficient than enzyme 1. Number 3, enzyme 2 will be more effective at catalyzing because the K2 value will be higher, as it took less to get to the point of transition from the ES to P. A lower Km of an enzyme means that the enzyme needs less substrate to saturate and will approach Vmax more quickly. And finally, enzyme 2 would have a higher affinity for substrate than enzyme 1. Okay, so here's what we're going to do. I want you to vote if you like an answer or not. Okay, so let's see what we've got. How many of you like answer number 1? Three? How many of you like answer number 2? All right, I think that's about 20 of you. How many many of you like answer number 3? How many of you like 4? There's some people not voting. How many of you like 5? Oh, okay. That's more. And more like 50. Okay, still there's some people who didn't vote. All right. Let's talk about these. Let's start with the most popular one. Number 5. Enzyme 2 have a higher affinity for substrate than enzyme 1. Anything disagreeable about that answer? I can find nothing disagreeable about that. Y'all agree? Why didn't Morgan vote for it? That's a good answer. Okay? All right. Let's go to number 2. That was the second most popular. If enzyme number 2 has a lower Km, enzyme 2 reaches the point where all of the enzymes are bound to substrate at a lower substrate concentration than enzyme 1. Is that true? Yes. Yes. That's good so far. But then the student adds, this also means that enzyme 2 is more efficient than enzyme 1. Is that true? No. How do we measure catalytic efficiency? Kcat over Km. And all we're talking about here is the Km. So 2 is actually a flawed answer. All right, so we like 5. 2 has a problem. It's good, and then it falls off. All right, let's look at number 4. A lower Km of an enzyme means that the enzyme needs less substrate to saturate. Is that true? Is that true? Needs less substrate to saturate. What does saturate mean? Saturate means to fill up all of those enzyme spots. What if I rephrase to say a lower Km means that the enzyme needs less substrate to get everything in the ES complex? That's what that's saying. Do y'all agree with that? Okay. But what about this? And we'll approach Vmax more quickly. We don't know about that, right? Because there we're getting into our K2. So both 2 and 4 have a problem in that part of them is right, but then they get into another parameter that Km doesn't tell us about. Km is independent of Vmax. It's part of catalytic efficiency, but not the full story. All right, number 3. Enzyme 2 will be more effective at catalyzing because the K2 value will be higher. That's wrong. That's just wrong, okay? All right. That one's no good. And then what about number 1? Not many of you like this. A higher Km means that for enzyme 1, so it's the one with the higher Km, the ratio of ES complex falls apart to ES forms is higher. Y'all want to vote again? How many of you like 1? What's the holdup? You're right. This is a good answer, but why do you not recognize that? Where are you stuck? Somebody asked me a question. Why does that not appear to be a good answer? Can anybody give me any insights? I'll help if I had an insight. Maybe you need to think about it a little bit more, I'm not sure. Can anybody tell me why you're stuck? Okay. I tell you what, go away and think about that. I think that's a good answer. Right? It's just the definition of this compilation of rate constant.